Hello guys, I got an email a few hours ago that I'm sure made your night for many of you kids that school is called off on Friday. I know that it's been such a very long time since we've had a snow day, but I hope you all have had a good time with the ice and snow and you've been able to get out and have some fun. I'm going to go ahead and start my timer here. This will hopefully help me to be able to keep up with time. What I'm going to do is I'm going to go ahead and do a videotape just as if I were in class of the lecture. So let's go ahead and pray. Father God, I am so thankful and so grateful for you and for your watch care over us and for the way that you provide for us so that we have food to eat and clothes to wear and houses to live in. Father, I ask that you would keep everyone safe during the remainder of this cold spell. Father, I ask that you'd help my kids to be attentive to the things that I'm trying to communicate with them through this videotape. Father, I ask that in the absence of a chance to work one-on-one and back and forth live, Lord, that you would reveal things to them, that you would give them insight, and they would be able to understand what we have that we're presenting in these sections. Bless our time in Jesus' name, amen. Okay, let me start out with two jokes. Of course, I have to find where the other one is. A Texan was trying to impress a guy from Boston with a graphic account of the heroism at the Alamo. He says, "I guess you don't have many heroes where you come from." The man from Boston replies, "Well, sir, have you ever heard of Paul Revere?" And the Texan says, "Paul Revere? Isn't he the guy who ran for help?" Sounds just like what a Texan would say. And then the second one is, what do ducks like to watch on television? Wait for it. Documentaries. So there's your lame joke. Let's go ahead and get started with class. It's been a while since we've been together. You have completed Chapter 7. What was due for class on Friday, February 4th, was for you to have completed Section 9 and 10 of Chapter 7 and to have completed the Chapter 7 review. The week before that, I had been in Missouri with my family for my father-in-law's funeral. I appreciate your prayers. We had a chance to share with people there, and God's just very, very good to us. But I was able to send you quite a few videos. I hope that you've looked at those on YouTube. Also, one of the last emails that I sent out said that you'd be able to watch the second part of Chapter 7.10 and that you would be able to watch the chapter review. If it's failed, they, however, are included with the DVDs that I'm sending you, probably on the opposite DVD from this. So I'm not going to spend any time in this video, which would be class on Friday, February 4th. I'm not going to spend any time at all going over anything from Chapter 7 or from the Chapter 7 in review. What I'm going to do right now is go ahead and teach the lesson, which is Chapter 8, Section 1, 2, and 3. On your other DVD that I've included in your packet, there will be some information about the Chapter 7 test. So what you're going to need to bring into class for me next week will be all of the homework that I have not yet collected from Chapter 7. You're going to need to bring me the completed Chapter 7 test, and you're also going to need to bring your homework from Chapter 8, Sections 1, 2, and 3. Now, if the weather permits, we will meet class up at Lakeshore on Tuesday at 3 o'clock. If you can make it, that'd be a great time to be there. You can clear up any questions that you're having about Chapter 7, any concerns you have about the test, or if there's something that you want to go over from Chapter 8. But for now, that's where we plan to be. We'll be completing Section 8.3 that will be due for your homework when we return to class next week. So let's go ahead and begin with Section 8.1. And what we're going to do now is more algebra, of course. Chapter 8.1 says that we're going to be talking about classifying and evaluating polynomials. And once again, we're going to be doing some vocabulary. Now, if you had a basket of fruit, and I brought it in, and there were some pears and some apricots and some apples and some bananas and some kiwis, so let's organize this or classify this. Probably what most of you would do is you would put all of the apples in one group. You'd put all of the kiwis in another group. You'd put all of the pears in another group. Well, that's sort of what we're talking about when we're talking about classifying and evaluating polynomials. But there is some more vocabulary that we need to learn. Let's say we have this expression. By the way, we're on page 324. Say that we have 2x squared plus 3x plus 5y minus 4x. Okay? This is a polynomial. All a polynomial is an algebraic expression. It's algebraic because it has letters in there, which are called variables, as well as numbers. Polynomial means that it has many parts to it. And these are terms. The first term would be 2x squared. The second term is positive 3x. The third term is a positive 5y. And the fourth term is a minus 4x. Additionally, with this polynomial, we have two terms that are called like terms. And if you can remember back to much closer to the beginning of the book, we talked about how, just like there's an old saying, you can't compare apples to oranges, you have to compare apples and apples. In other words, things have to be the same before you're able to accurately and adequately compare them. Like terms, you see the numbers in front of them. The numbers are called coefficients. The numbers don't have anything to do with whether or not an algebraic term is a like term. But for these two to be like terms, the variable has to be the same. Here it's an x. And the exponent is the same. This is x to the first power. Over here we have an x squared. X squared and 3x are not like terms because even though they have the same letter, the exponent, a 2, and that's understood to be a 1, they're different. So we say that like terms have to agree both in variable and in degree. The degree is the exponent. So if we combined our like terms here, we would have 2x squared plus 3x minus 4x becomes minus x plus 5y. And what you see here now is we have an algebraic expression that has three terms in it. 2x squared, negative x, positive 5y. Now, most of us, when we were growing up, we didn't immediately jump on a two-wheel bicycle and ride. We started off with a tricycle. Tri from the Latin meaning three. This is a polynomial. These are expressions in many variables, with many terms. That's polynomial. Polynomial. This, however, is called a trinomial. It is a polynomial because it has many terms to it, but can specifically be called a trinomial because it has three terms. Now let's say that we had this expression here. This has two terms to it, a positive 2x squared, and it has a positive 4. So what do you think this is going to be called? Yeah, see, this is not hard. It's a binomial, two terms, binomial, as in a bicycle. And then A single term all by itself, that's going to be called a monomial. Monomial. So these are the four ways that four pieces of vocabulary we have. We have a monomial, we have a trinomial, we have a polynomial, we have a binomial. Okay? Now we're going to talk about the degree of a polynomial. This is review also. But the degree of a polynomial, and I'm going to refer you to your book, page 324. The degree of a term is the sum of the exponents and the variables. So we have the degree of a term, and we have the degree of a polynomial, which is on page 325. The degree of a polynomial is the degree of the term with the highest degree. So I've used these four expressions here to show you polynomial, trinomial, binomial, monomial. Let me change them a little bit so that we can talk about the degree of a polynomial and the degree of a term. I want y'all to notice I've got a sweatshirt on. I know you thought I surely never got cold. Well, we're keeping our temperature down a bit in our house. So I'm feeling pretty happy to have this sweatshirt on. So let's just go ahead and do 5x squared plus 2x plus 6. 5x squared plus 2x plus 6. So this is the degree of the term. Right here, this is the sum of the sum of the exponents. Degree of the term, and then we have the degree of the variable. The degree of the term is the sum of the exponents in that term. The degree of the variable is the degree of the term with the highest degree. So we have three terms here. You sum the exponents here, that's a squared. That's a first degree, that's a 0 degree. So the degree of this term, it's second degree. The degree of the entire, I said variable, it's the degree of the polynomial. And this was where I was reading directly from page 325. The degree of the polynomial. Polynomial. The degree of the polynomial is the same as the degree of the highest degree term. This one right here is a second degree term, so this becomes, since that's second degree, first degree, 0 degree, this is the highest degree term, so it is a second degree trinomial. We can have a trinomial that looks like this, x squared y z to the cubed plus 2x y squared plus 6. This is still a trinomial. There are still three terms. First term 5x squared yz cubed. Second term positive 2xy squared. Third term positive 6. And this is also positive. Well, what's the degree of this term? 2 plus 1 plus 3. So this is a 6th degree term. This one right here, 1, 2, 3. This is a 3rd degree term. Obviously, the 6th degree term is the highest degree of any of these terms here. So this expression is described as being a 6th degree polynomial. specifically a trinomial. Now this is sort of like beating a dead horse, me trying to go over some of this vocabulary on the video. You just have to sit down and learn it. Yeah, that's just pretty much how this vocabulary is. Okay, what I've done is I've set it for 3 15-minute sections to make sure that I can stay reasonably on track. So, let me look and see how many of these examples I want to do. This is just really, really straightforward. Let's go ahead and look at example number 1. Let me grab this, go ahead and start it again. And I'm not going to do a lot of editing on this video because this would be just like having a live class. Let me see if I can get this board cleaned off. And we'll go ahead and do example number 1, which is really exactly like the example that I just showed you. Same idea as what I made up from my head. This asks us to find the degree of this polynomial, 3x cubed y plus 2x plus 4xy squared. We're on page 325. So, our first term is a positive 3x cubed y. We want to add up the exponents. So that's 3 plus 1, so that's 4. We have our second term, which is a 2x. The exponent there is just 1. We have our third term, which is a positive 4xy squared. So we have the exponent on the y is 1, plus 2. So we have one term that's a 4th degree term, this is a 2nd degree term, and this is a 3rd degree term. So this is a polynomial, but it is specifically a trinomial because it has three terms, and if this is a 4th degree trinomial, well, degree trinomial because the degree of this term here is 4, and it's the highest degree of any of the terms in there. So this expression is a 4th degree trinomial. See, it's very, very easy. Now, let's see here. We're going to substitute in to evaluate a trinomial. Let's go ahead and do example number 3. This needs to be nothing but pure review for you. This should be very, very straightforward, easy, simple review where you're substituting in a value for the variable. You know what? All of these that I've been doing, I feel so very silly right now because now I see that I can turn my screen and I can actually see that I am looking exactly where I need to look. Somebody say, oh my goodness, one of my favorite Bible teachers is Beth Moore. Love listening to what that woman has to say. And she has an expression that says that she is blonder than she pays to be. So I guess we'll just pretend that I'm blonde instead of gray and say I am so much blonder than I pay to be. I cannot believe that I just now figured out I could turn that screen around and look while I'm recording. So anyway, moving right along, we are back at example number 3 on page 325. Evaluate 5x cubed y plus 2x minus 3y plus 5 when x is equal to negative 2 and y is equal to 1. So I think I'll go ahead and write this one down. This is example 3, and we are on page 325. We have 5x cubed y plus 2x minus 3y plus 5. And we're going to evaluate that when x is negative 1 and y is equal to 1. And actually, x is a negative 2. Now, see what I'm doing? Right now as I'm talking with you, I'm going back and I'm checking to make sure that I've copied everything right. You guys need to do that as well, because when you do that, you'll catch your mistakes. 5x cubed y plus 2x minus 3y plus 5. X is a minus 2 and y is 1. Okay, so we're just fine. Remember when we've talked in the past about substituting values in for variables and enclosing those in parentheses? We have 5 times a negative 2 cubed times y, which is 1, plus 2 times a negative 2 minus 3 times 1 plus 5. 5 times negative 2 cubed gives us a negative 8. Times 1 plus 2 times a negative 2, that's plus a negative 4. Minus 3 times 1, minus 3, plus 5. 5 times negative 8 is negative 40, times 1 is negative 40, plus a negative is minus 4, minus 3, plus 5. Negative 40 minus 4 is negative 44, minus 3 is negative 47, plus 5 is negative 42. Ha, look at that. Smeared that quite perfectly. So negative 42 is the solution to section 8.1, example 3. We'll go ahead and move on to section 8.2. Section 8.2 is adding polynomials. And this really is just building on stuff that you already know. This should be a nice easy week's worth of homework. It's actually a good one to try and do on your own with just the videos. Adding polynomials, page 327. When you add polynomials, you can align like terms for vertical addition. Most people, if you have a long string of things together, they like to add them in columns instead of horizontally. So let's look at example 1 on page 327. Add 3a plus 2b minus 8c plus 8 and 2a minus 4b plus 4c plus 9. I'll show you both ways you can do this. This says 3a plus 2b, this is example 1, 3a plus 2b minus 8c plus 8, and then it says and, so that means plus, we're going to have that, and we're going to add this together. 2a minus 4b plus 6c plus 9. Because we're adding, we're not subtracting, the signs aren't going to change. So I'm just going to go through and do this horizontally. 3a plus 2a is 5a. 2b minus 4b minus 2b. Negative 8c plus 6c is not equal to a positive 6c. It's equal to a negative 2b. Not a negative 2b. Negative 8c plus 6c is a minus 2c. Plus 8 plus 9 plus 17. if we just add this horizontally. However, we can also set this up vertically. What we want to do here, we have 3a plus 2b minus 8c plus 8. 2a minus 4b plus 6c plus 9. You can know that we're going to add these. You add the coefficients when you have like terms. 5a minus 2b minus 2c plus 17. The solutions are the same. When you're just adding basic polynomials together like this, we have a 4-term polynomial, that we're adding a 4-term polynomial. There's really not a whole lot of difference in the ease of addition, no matter which way you choose. But let's go ahead and look at our next example. And I think you'll see why sometimes it might make sense to go ahead and add vertically. Now actually what this is doing is this is preparing you to solve matrices, which you won't need to worry about for a while, but this is just another example of how so much of everything that you learn is foundational to something else in algebra, which is important for this next step, which is important for this next step, which is important for this next step. It's sort of like if you learn to ride a bicycle, or play an instrument, or read, when you turn and look backward, you think, man, it used to be such a big deal for me to be able to balance on my bicycle and not fall off. Or I thought it was really great when I read my first chapter book, and there were a total of 3 chapters, and each of them had 5 sentences in it, and now you're reading A Tale of Two Cities or something. But you're going to be doing that same thing in algebra. You're getting these foundational things, and as you move on in your upper level math classes, you can look back and say, wow, look at how far I've come from just adding polynomials together. Let me go ahead and take example number 2. 2x squared plus 3xy plus 5y squared. 2x squared plus 3xy plus 5y squared is the first polynomial. We know it's a polynomial all grouped together because it's enclosed in parentheses. So we have that trinomial, and then we have another trinomial. 8x squared minus 5xy plus 3y. Does it go here? Plus 3y? No, we've got a y squared here. So you only add up, only put like terms underneath like terms. So you have plus 3y. I can actually go ahead and write in a 0y. So that you see, let me make sure that that's all in there. Yeah, it looks like it is. It's hard looking at it backwards. Okay, our third expression is a binomial x squared plus 2y squared. 2y squared. So we're going to add this. I'm just going to write add here to remind me that I'm adding. 2x squared plus 8x squared is 10x squared plus 1 more x squared. 11x squared. 3xy minus 5xy minus 2xy. 5y squared plus 2y squared plus 7y squared. 0y plus 3y is plus 3y. And let's make sure we have 11x squared minus 2xy plus 7y squared plus 3y. So this is an illustration of how you can add your polynomial expressions vertically. Now, let's move on just a little bit more in this section. It seems to me that it's been a long time since I had my timer set. 17 seconds. Okay. In the middle of page 327, you can also add polynomials horizontally, which is what I've been doing. To add polynomials that contain parentheses, what we want to do is remove the parentheses by distributing. Be careful with those negative signs. Remember, the negative signs will trip you up. If you're not careful, you need to make sure that you're being on the lookout for that. So let's go ahead and do example 5 on, let's see, example 5 really isn't hard. Let me see. Let's go ahead and do example 5 anyway. This says add negative 5x plus 3xy plus 7y plus 9, and then in your book it has a comma after that 9, so that tells you that this is the first polynomial, or the first term that's going to be added. So we have that. Now we want to add 5x squared plus 3xy plus 8y squared. Then they have a comma again. So this is the second polynomial. And then they say, and 10. So we have 3 expressions that we're going to combine together. First, we just have a polynomial in 4 terms. Second, this is a trinomial, 1, 2, 3 terms. And then we have a monomial. So if you want to add these horizontally, you can add them horizontally, you can add them vertically. To help you know how to put things in order, it's best if you can pick one of the variables and start with the highest number, highest degree, x squared, x to the first, x to the 0, which is 1, and then here we're starting out, there aren't any y's, so it's y to the 0, y to the first, y to the second. Remember our slope, we had a decreasing slope. If you'll start with your highest degree variable and work down at the same time as you have the lowest degree, when you have more than one variable, lowest degree, and work up. That will help you to organize your polynomial expressions a little bit more clearly. I'm just going to look at them and cross them out as I add them. 5x squared, 5x squared. No more x squares, so this is going to be my highest degree variable. So I'm going to look for just, is there a 5x by itself? I mean, is there an x by itself? Where here's an x, but it's not plus. It becomes minus 5x. Minus 5x. Any more x's? No. Okay. Well, how about if we do the xy's next. Plus 3xy plus 3xy is plus 6xy. And I guess I'm going to do the 7y next, plus 7y, plus 8y squared, plus 8y squared. We have a plus 9 and a plus 10, plus 19. Now let's see how what I came up with compares to what they did in your book. I feel pretty sure it's going to be slightly different. 5x squared minus 5x plus 6xy plus 7y plus 8y squared plus 19 was actually the same. Sometimes, you know, they're not always real neat, but you can see that the x's go down. The y's increase according to the degree, and we end with the constant term. All you're doing is putting all of your apples together, all of your oranges together, all of your kumquats together, all of your particular expressions together, your terms and your math. What you're doing when you're combining them is you're making sure that the variables are the same and that this little number here is the same, that the exponent is the same. That's how you tell if it's an apple or a pear or a banana. And that's how you know what to group together. That's all 8.2 is. Let's go ahead and look at 8.3 now. See, you should be breathing and thinking, oh wow, this really is going to be really straightforward. This is subtracting polynomials. Can you change a subtraction problem to an addition problem? You should be able to, because you learned way back in Chapter 1 that subtraction is the same as adding the opposite. When you subtract polynomials, you'll follow the same procedure. To subtract, you add the opposite. Okay? Let me go ahead and erase this board one more time. To subtract, we add the opposite. Now I'm going to teach you the way that they say to do this in your text. Now if you're comfortable just straight subtracting, by all means do that. And if you wonder what I just said, just add the opposite. This is example 1 on page 330. Page 330, example 1. This is section 8.3. We have simplify 3x squared plus 2x minus 5 minus the quantity, minus the quantity 4x squared minus 5x plus 2. Okay, I'm going to have to walk up here and make sure this is really recording. Okay. What we have here, we have two trinomials. 3x squared plus 2x minus y. This is all collected together. It's considered one polynomial expression because it's in parentheses. And from that, we want to subtract this second thing. Now remember, subtraction is the same as adding the opposite. So what they're saying is we have this first expression, 3x squared plus 2x minus 5, and we want to add the opposite. Well, if we're going to add the opposite, we're going to take the opposite of every term that's inside. We have a positive 4x squared negative 4x squared plus 5x minus 2. Subtraction is the same as adding the opposite. If we're subtracting a 4x, we're adding the opposite, adding the opposite, adding the opposite. That's what they're doing as you look through your example in your book. Let me glance at this just for a minute. Then they're going to remove the parentheses. 3x squared plus 2x minus 5 minus 4x squared plus 5x minus 2. 3x squared minus 4x squared minus x squared plus 2x plus 5x plus 7x minus 5 minus 2 minus 7. Let's see if I agree with the book. Negative x squared plus 7x minus 7. Now, if you simply distribute the negative sign, you're going to arrive at the same answer, just really a different theoretical approach to it. So I have 3x squared plus 2x minus 5. Now I have this negative 1 that I'm going to distribute to every term inside the parentheses. So the opposite of 4x minus 4x squared minus a negative plus 5x. Now we go there. Plus 5x, negative times a positive, minus 2. Same thing as adding the opposite. 3x squared minus 4x squared, negative x squared plus 2x plus 5x plus 7x minus 5 minus 2 minus 7. You end up with the same answer, whichever way you find to be the more intuitive or the more easy for you to track with. Do it. Maybe you want to do this vertically. Let's see if I think I'm going to go ahead and do example 2 on page 330. And let me give you a hint on chapter 8, especially right here at the beginning, 8.1, 8.2, 8.3. This is a part of your book where it's really possible to overthink it. If you look at it, you're going to try and make it harder than it is. Use those things that you've already learned, that I've taught you, that you've discovered on yourself, that the Lord has helped you to make clear in your mind, and just add and subtract the coefficient of the like terms. Don't get all hung up in trying to find exactly the specific formula that they're using. That'll make it difficult for you. Just don't overthink it. You're just adding and subtracting. So let's go ahead and look at example 2. Once again, this says simplify. So we're on example 2. 5a minus 7b plus 6c plus 10, and then it says minus, and I'm going to carry it down to this next row here.